friends, welcome back to our channel. Today we are going to discuss about constraint equations. In previous content we discussed about constraint motion. Right now how we can get a relation between the blocks directly we are going to find by using constraint equation. Constraint equation is a relation which relating the motion of the we can consider acceleration or velocity of the blocks, okay, which are considered under system. Right now coming to first content. Right now here two blocks are there, two blocks which are connected with a string, only one string we are considering. And here how to find constraint equation means first we need to consider one reference line. Here this is the reference line we are considering, okay. You can consider here also one reference line we are taking. One reference line we need to consider at any place which is constant, okay. Here how many blocks are the pulleys are movable we need to consider. Here in this case only two blocks are movable, so we need to take first block length from reference line is x1, second block is x2 from the reference line. How many strings are there here? Only one string here is there, only one string. So how many equations we will get? Only one equation we will get. So that what we will get, total length of the string we need to consider. Here over the pulley the string length remains constant, so that we are not considering above the reference line, okay. So that we are taking the reference line at the center. So we are getting x1 and x2. Here this is x1 and this is x2. So x1 plus x2 is equals to L. Okay. Here this is the equation we are getting, which is giving you the relation between the objects or nothing but blocks. Okay. Differentiating with respect to time dt. Okay. If we differentiate displacement with respect to time, displacement by time is called a velocity. So we'll get displacement divided by time is giving you velocity. So if we differentiate it once, we are getting velocity. First body v1, second body is v2. What about L? L length remains constant. Differentiation of a constant is 0. So we are getting v1 plus v2 is equals to 0. If we differentiate it one more time we are going to differentiate this. Rate of change of velocity, change in velocity by time. So we will get acceleration. So this is the differentiation. So we will get v1 differentiation is a1, v2 differentiation is a2. Okay. How it will be means we can take dv by dt is equals to acceleration a. Okay. Here we can take displacement divided by time is nothing but velocity. Okay. These are the two equations we can consider. So a1 plus a2 is equals to 0. So finally we are getting a1 equals to minus a2. Okay. Here is the equation we are getting. But what is the negative sign is indicating? We can take a1 equals to a2. If we consider one string, acceleration of both the blocks remains same. But why we got a negative sign? And what is the reason behind of that? Means first body is coming down, this body is going up. If the displacement is giving you increase, the displacement is giving you decrease. So what will get a1 equals to a2, both the accelerations are same, negative sign indicating opposite in direction. Okay, this is one case. And coming to second case, here we are taking two blocks, two strings, one movable pulley. Okay, first body, second body. One is movable pulley we are considering. Again we are taking, this is the system, two pulleys are connected here, two blocks are connected. The string, first string is passing over like this. Okay, second string separately connected to block 2. Right now again we are taking one reference line so that we can calculate distance from the reference line. And first we need to check how many which are movable. First body movable, second is movable, and this pulley is also movable. And what about this? This is fixed from the rigid support. So what do you get here? This is the reference line. We are taking first block x1, from the reference line, length is x1, and second block, where is it from the reference line? Here is it. So we are taking x2 is the distance, okay, and the third one, pulley distance is x3. From the reference line we need to consider 3 distances we measured. After that we need to take what is the length of the string. How many strings are there? 2 strings. This is one string. Second one is, this is second string. First we are considering first string. What is the length of this? x3. Again, length of this x3 again. Length of this x1 again. So x3 plus x1 is equals to length L1. Okay. And 2x3 is plus x1 equals to L1. Differentiation with respect to dt 2 times we need to take. Why? Because we need to get in acceleration. So we are differentiating 2v3 according to this relation, and v1 equals to 0. Constant. Length remains constant even they are moving up and down. Okay. Even they are moving up and down, length of the string remains constant. Okay. So that differentiation of a constant is giving you 0. One more time, if you differentiate this equation, so you get 2a3 plus a1 equals to 0. So this is the equation number 1 we are considering. And coming to second, here is the second length. Length of the second string is this. So we need only this length. What is the length here? It will be for x2. For second block is x2. And this is the length we are considering, x3. So if we subtract x3 from x2, then we'll get length of the second string. So x2 minus x3 equals to L2. So differentiation, we are getting v2 minus v3 equals to 0. a2 minus a3 equals to 0. And we are going to find a relation in between 1 and 2. Okay, we are going to find a relation between first block and second block. No need of pulley. So we need to eliminate acceleration of pulley so that we'll get the relation between 1 and 2. So from equation number 1 and 2, what will get? a2 equals to a3. a3 is nothing but minus a by 2 from this equation. We can substitute. So directly I am writing from equation number 1 and 2, a2 equals to minus a1 by 2, where negative sign is indicating that direction itself. Okay, this is the block which is coming down, this is the block which is moving up. Why? Because when it is coming down, the string pulls down. Then what happened? The string which is moving up. So then what happened? The block, it rises up. Okay, so if it is coming down, this will move up. Okay. This is one method, and we can find the second method also. Here with the same diagram we are considering, this is giving you second method. Not only that, here the second method for this we can calculate very easily. Shortcut method. Here the first block, second block, pulley. No need of considering any reference line in this second method. Just one rule will be there. Tension into acceleration. The algebraic sum of tension and acceleration is equals to 0. This is the formula we need to take. Summation. We need to add all. Okay. Summation, tension in the string and acceleration. Okay. What is the tension in the string? What is the acceleration of the block? We need to consider, add all the terms which are given in the system. So then we'll get finally one equation that is giving you the relation between blocks. Okay, right now coming here, if you consider this block, it pulls downward direction, so the tension produced in the string is T. If you consider one string, if it is massless, only tension remains constant. So tension in this string, only one string, tension remains constant at anywhere. Okay, this is the tension T, this is the tension T, and this is also tension T. Here tension T in upward direction, here tension T is in upward direction. What will get the tension in this? It gives you T and T. Combine it together, 2T will be the tension. Okay. So what is the tension in the string? This is giving you 2T. Here what is the tension in the string? T. Tension into acceleration. Tension into acceleration. Okay. algebraic sum is equals to 0. So directly I am writing here tension into acceleration. What is the tension in this? T. What is the acceleration? A1. What is the tension? 2t. What is the acceleration? A2. So T A1 plus 2t into A2 equals to 0. Tension getting common. Set it right. It becomes 0. So what will get? A1 plus 2A2 equals to 0. If you set it right, 2A2 equals to minus A1, A2 equals to minus A1 by 2. Here this is the equation we got here. Okay, as it is. What will get? The negative sign? Negative sign indicating that direction itself. Okay, this is the second method, finding the relation between the blocks. Here we have one more case. Block 1, block 2. And we are passing our pulley. This is string 1 and this is string 2. Two strings we are using. How many movable objects are there? 1, 2 and 3. Totally we have 3 movable objects. One is pulley, 2 are the objects, nothing but blocks. Here we are going to find the relation for first block and second block. Already I gave one relation for this, directly I gave, but how to find relation between first block and the second block, right now we are going to identify. Here we need to consider reference line. Here from this point I am taking reference line along horizontal direction and vertical direction, so that here this is the distance x1 and here this is the distance for this pulley is x3 and for the block is x2 from the reference line. Okay, how many strings? This is the string 1. So we are going to find the relation x1 from here to here x1 and here to here x3 and here to here x3. Totally we will get one relation x1 plus x3 equals to string length 1. Okay, coming to string length 2. This is the string length 2, x2 total distance minus, if you subtract this then we will get the length of second string. So x2 minus x3 equals to L2. After differentiation we are getting a relation directly. I wrote here 2 times a differentiation with respect to the time. So we are getting a relation A1 plus 2A3. A3 plus nothing but x3 plus x3. 2A3 we have got first equation we are taking. X2 minus x3 is equals to L2 second string. If we differentiate it 2 times, A2 minus A3 equals to 0. Okay, combine it together we are getting a relation A2 is equals to minus A1 by 2. Why? Because A3 equals to minus A1 by 2. If we substitute in this, then we will get a relation here minus of if I send it right side, then we will get A2 equals to minus A1 by 2. Okay, this is the relation we are getting for the block 1 and block 2. Okay, coming to next case. Here we are taking one system like this. How many movable objects we need to identify first? First 1, 2, 3 and pulley. Totally 4 movable objects are there. In this we are going to find 1, 2, 3 relations only, but not with the pulley relation. Okay, pulley we are not considering here. If you want pulley relation you can consider depending upon the given relation. But here relation is in between objects, blocks only. So first, second, third we are considering. First block distance is x1, second block distance is x2, third block distance is x3 and fourth one pulley we are considering. So I am taking it as x4. First block x1, second block x2, third block x3. For easy to identify 1, 2, 3. And fourth one we are going to eliminate. So no need of that. So that I am taking in order 1, 2 and 3. So what is the length of this string? First string x1 plus x4. x1 plus x4 is giving you length of this string. x1 plus x4 equals to L1. Differentiation, so we will get a1 plus a4 equals to 0, a1 equals to minus a4. First equation. And coming to second, what is the length of this string? This is the second length string. So we need the length of this. How to find length of this? x2 minus x4. So we'll get length of this. So we got x2 minus x4. And coming to second length. So x3 total length minus, if we subtract this, so we'll get length of this. So we'll get x3 minus x4 equals to L2, second length. Here x4 2 times is there, so we'll get minus 2x4, x2 plus x3. This is the second length string we got. And after differentiation, a2 plus a3 minus 2a4 equals to 0. Right now we got two equations, first and second. But a4 equals to minus a1 you can write. So that what you'll get, minus of minus, it becomes plus. So 2a1 plus a2 plus a3 equals to 0. This is the second relation. This is the equation we got in a1, a2 and a3. First block, second block and third block relation. If they will give you problem like this, if a2 equals to 4 meter per second square upward direction, okay, this is moving up, okay, a3 is coming down. What happens to the block 1? Is it moving upward direction or downward direction? According to this relation we can consider, okay. If it is upward direction, we are considering just it is as a negative. When it is coming down, just we are considering it as positive. Coming down positive, going up negative. So here we took values 4 meter per second square, 6 meter per second square for a2 and a3 respectively. So if we substitute these two, upward we consider negative sign, minus 4 meter per second square plus 6 meter per second square, okay. a2 value, a3 value, if we substitute, then we are getting a1 equals to minus 1 meter per second square. So a1 equals to 1 meter per second square. What is negative sign? Negative sign we consider moving upward direction. Nothing but if it is moving up, this is coming down, and then what happens, the resultant block, first block will move, means in upward direction by 1 meter per second square. Okay, here this is one problem which is given here with the values. Okay, you can do calculation with some other. And second method also you can use in this case. Okay, and coming to next case, here a complex system will be here. Block 1, 2, 3, 4. Totally 4 blocks are there. And how many pulleys are there? Here 1, 2, 3, which are fixed. Here this is moving. This is moving, this is moving, this is also moving. Okay, if we take what we call it as equations, length, then it gives you lengthy process. For easiest way, already gave a second method, okay, to finding the relation between blocks with the acceleration term. Okay, so for that we are taking second relation, second method. Here just I am considering it as a tension T in this upward direction and also downward direction. Okay, here in a same string, tension remains constant, T again. This is also gives you the same tension, but because only one string. Okay, T and T combine it together, this becomes 2T. In this same string, so we'll get this also becomes 2T. 2T plus 2T gives you 4T. And here this is the same string up to here, so we'll get this is also gives you 2T, and this is also giving you 2T. 2T and 2T is giving you 4T. Here this is also giving you 4T. 4T and 4T becomes 8T. Okay, 4 plus 4, 8, 8T. Here this is also same string, so we'll get 4T again. Okay. This is the block we are considering acceleration A1, A2, A3, and A4. So according to the relation, summation tension into acceleration is equals to 0. So tension 40 into A1 plus 80 into A2 plus 40 into A3 plus T A4 equals to 0. T getting common, hands in it right, becomes 0. So we are getting relation 4A1 plus 8A2 plus 4A3 plus A4 equals to 0. Okay, this is the equation we are getting very easily to find the relation between the blocks. Okay, on basis of this, if they'll give you values upward direction, downward direction, we can calculate any one of the value which is given in the system. Okay, this is about one case. Like this, so many cases we'll have. We can solve very easily by using two methods. Okay, if it is a very big system of what we call it as number of blocks and pulleys, we need to solve with summation tension into acceleration equals to 0. If it is small system, directly you can calculate like this, or you can do shortcut. Okay.